Hi, welcome back to my channel, Physics Form 4 KSSM. Today we'll continue Chapter 1 Measurements on Topic 1.2 Scientific Investigation Part 1. In this video, I will discuss two learning standards. The first one, interpret graph to determine relationship between two physical quantities. The second one, analyze graph to summarize an investigation. Scientific investigation is one of the important part in physics. As a physics student, you must be able to carry out experiment, analyze the data recorded, draw out conclusion, and then discuss some of the suggestions to increase the accuracy of the result of this experiment. Okay? Scientific investigation involves the scientific method. The scientific method involves a series of steps that are used to investigate a natural occurrence. Things that happens around us sometimes will cause some question to arise. In order to get the answer for the question, so we need to carry out an experiment. Okay, that's what scientists do. Okay. Okay, the first one we want to discuss about interpret graph to determine relationship between two physical quantities. The two physical quantities involved here is manipulated variable and responding variable. I hope you still remember what is manipulated variable and responding variable. And also we will use some of the mathematics operation in order to answer or to solve a question involving graphs. Okay, recall what you studied in Maths Form 3, linear equation, y equals to mx plus c, c is the y-intercept, and the gradient can be determined by using this formula m equals y2 minus y1 divided by the x2 minus x1. Let's say from the data recorded, when you plot a graph, you get this shape of graphs. What we can say about the shape of the graphs? Look at the first one. A straight line passed through origin. The graph shows a straight line that passes through the origin. The interpretation of the graph means you state the relationship between y and x. In physics, y is responding variable and x is manipulated variable. So for this graph, we can state the relationship as y is directly proportional to x. The linear equation for this graph, based from the linear equation here, y equals to mx plus c. Because of the line of graph passed through origin, the value of c equals to 0. Thus we get y equals mx. The second graph is also a straight line graph, positive gradient. But the line of graph intercept at one point at y-axis. What we can say about this graph? A straight line with a positive gradient that does not pass through the origin. The interpretation of this graph will give relationship as y increases linearly with x. The word linearly means straight line. Y is equals to c. Y-intercept is equals to c. Thus, generally, we can write the linear equation as y equals mx plus c. The third graph here is also a straight line graph, but the gradient is negative. What we can say about this graph? A straight line with a negative gradient that does not pass through the origin. Interpretation of the graph gives the relationship as y decreases linearly with x. And the linear equation for this graph, y equals to mx plus c. Thus, for this part, based on the shape of the graph, you must be able to state the relationship between responding variable and manipulated variable. Okay, next graph is a curve graph. Okay, for number 4, you can see the line or the curve line curve upwards. This one curve downwards. But for this one, the gradient is positive. A curve with positive gradient that passes through the origin. For curve graph, gradient is not constant. Meaning if you determine the gradient at certain point on the graph, you can see the gradient are not the same. Okay, so for this one, it will give gradient, which is positive gradient. Okay, so interpretation will give relationship as y increases with x. Okay, number 5 here is also curve, but for this one is negative gradient. Interpretation of the graph will give relationship as y decreases with x. And the last one here, this is also curve graph, but what is the difference between this graph and this graph? This graph will never intercept at y-axis or x-axis. The line of the graph will approach y or x only, does not intercept. Dia tidak akan memotong pada y atau x, dia hanya menghampiri sahaja. Okay, so if you get this graph, this one will give relationship as y is inversely proportional to x. Let's say if we change the delta x to become 1 over x, and then we plot a graph again, y against 1 over x, we get a straight line pass through the origin. Thus, we also can state the relationship between y and x as y is directly proportional to 1 over x. Okay, so for this type of graph, there are two relationships that you can use. You can use the first graph as y is inversely proportional to x, or you can use the second graph, y is directly proportional to 1 over x. Okay, so this one, there are 6 types of graph. So based on the graph, you must be able to state the relationship between two physical quantities. Okay, next, analyzing graph to summarize an investigation, meaning in order to write a conclusion based on the result of the experiment. Analyzing graph, the first one we have done, we have discussed about relationship between two variables, responding variable and manipulated variable. The next one, what we can get from the graph, the first one, we can get the gradient. Sometimes the gradient of the graph will give another value for physical quantity. Okay, area under the graph, interpolation to determine value of physical quantity, extrapolation to make a prediction. So we are going to discuss this one by one. Okay, the first one, relationship between two variables. The method just now we have discussed, interpret the shape of the graph obtained. The second one, the gradient of the graph method, calculate the gradient of the graph M by using the formula, mathematical formula that we discussed earlier. Let's look at this graph. How to determine the gradient of the graph? In physics, in order to determine the gradient of the graph for a straight line, the first step that you do is you need to choose 2 points on the line, and then you draw a triangle below the line from that 2 points. The triangle that you draw must be large enough. At least the minimum size is 4 times 4 largest square if you look at the actual graph paper. Okay, or 8 cm height and 8 cm width. That one is the minimum size. Actually, the larger the size of the triangle, the more accurate the value that you get. Okay, So gradient of the graph, we use the formula m equals y2 minus y1 divided by x2 minus x1. Okay, so meaning from here you can see this delta y equals to y2 minus y1. This one is the height of the triangle. Delta x equals to x2 minus x1. This one is the width of the triangle. So you can see the gradient equals to the height of the triangle divided by width of the triangle. And in physics also, you need to state the unit for the answer or for the gradient that you calculate. Look at this one example. Let's say we have displacement against time graph. The first step that you need to do is draw a triangle below the line. Let's say the height of the triangle is 10, the width of the triangle is 5, thus the gradient equals to 10. 10 is the height. You can see the unit here is meter, so meaning 10 meter. For 5 here, the unit is second, 5 second. Simplify, so we get 2 meter second to the power negative 1. So you can see here the final answer, there must be a correct value and unit. Okay, so it's very important for you all to state correctly answer with unit. The third one is area under the graph. Sometimes the area under the graph will give another physical quantity. Method, calculate area under the graph using relevant formula for the area. For example, this graph. They want you to determine area under the graph from this point to this point. So the shape is trapezium shape. Okay, if you know the formula of trapezium, you can use straight away the formula of trapezium. For example, area equals to half times x2 minus x1 times bracket y1 plus y2. So this is the trapezium, okay, formula. Or if you don't know the formula of trapezium, you can divide it to two sections, rectangle and triangle. So what you do, you calculate separately the area. At the end, you just total up. Okay, so area of the triangle plus area of the rectangle. Okay, so you will get the area of the shaded region. Okay, look at this one example. Velocity v meter second to the power negative 1 against time t unit second. Let's say the height of the triangle here is c, the width is d. So the area under the graph for this graph equals to half c, the unit is meter second to the power negative 1, d, the unit is second, thus we get half cd meter second to the power negative 1 multiply second. Okay, so you will get half cd meter. So you can see here area under the graph for this one will give another physical quantity, distance or displacement. That's why analyzing graph sometimes will ask you to find area under the graph. Okay, number 4, the interpolation to determine value of physical quantity method. If the value of x is given, determine the value of y using interpolation. So what you do, the first step, you need to draw interpolation line. Let's say we have this graph. Interpolation line is the line that you draw. You can see this one, the pink color line. Okay, let's say when x equals 1.5, you need to find the value of y. So this is 1.5. So what you do, you draw a line. Normally for interpolation line, we use broken line. Okay, so this is interpolation line. So x 1.5, you draw a line to the graph and then you draw from the graph to the corresponding value. Okay, here. And then you read the value here, you write the answer. So x equals 1.5, so y equals 38. Okay, or y equals 25. For example, given y, so y 25 here, you draw interpolation line to the line of graph and then draw down to x-axis, so you will get 2.4. Okay, so it's very important for you all to draw this interpolation line. Look at example here. This is a graph of speed against time. Let's say the first one, you want to find v when t equals to 10. One value always given. They must give you one value. Okay, for example, given is t, 10 seconds. You want to find v. So what you do, t times second is here. So you draw interpolation line. And then from the graph was here, you draw corresponding value to the corresponding value. Okay, so here you get 26 meter per second. Okay, or the other one, given v, you want to find t. Given v 30. Draw interpolation line to the line of graph and then continue drawing down to time, to the time axis. So you will get the answer, that is t equals 15 seconds. Okay, so this interpolation line is very important. You must draw the line and then state the answer. Okay, number 5, extrapolation to make a prediction. Ramalan. Okay, method, extrapolate the graph, meaning draw extrapolation line, determine the value of x or y concerned. Okay, for example here, line from experimental data, meaning from the experiment you just get the data starting from 2 to 5 only. So this is range of data that you get. Okay, let's say they want you to determine something which is out of range. For example, determine the value of y when x negative 3.2. Negative 3.2 is out of range. So what you do, you need to draw extra line or extrapolation line. So you can see this blue broken line, so we call it extrapolation. Once you draw extrapolation, so you can get the value of y for x equals negative 3.2. Okay, so and then after that you can just continue drawing this pink line, okay, this pink broken line. Okay, so you will get the value of y equals to 1, or given the value of y 3. 3 is also out of range. Okay, so you get x equals to 1. So we use this extrapolation line to predict the value of y when given x, or to predict the value of x when given y. Okay, look at the example. Look at more example on this. For this extrapolation line, sometimes extrapolation line also need to be drawn for hanging graph in order to determine relationship between responding variable and manipulated variable. Let's say given a graph like this. This is a hanging graph. For hanging graph, we cannot determine the relationship between y and x. So the first step that you need to do is you need to extend the line or draw extrapolation line until here. So this one we call it extrapolation line. Then only we can state the relationship as y increases linearly with x. Okay, so that's the use of extrapolation. Okay, next, table of data. Let's say we have this table of data. Based on the table of data, you must be able to plot a graph. You have studied this one in lower form, how to plot a graph. So we have manipulated variable h or height, unit centimeter. We have 5 values. Then we have the value of s in centimeter, displacement, recorded also 5 value. Then calculated value v, centimeter second to the power negative 1, also we have 5 value. So in this case, s and v represent responding variable. S is the primary data because you measure throughout the experiment. The V is secondary data because use formula to calculate the value of V by using the value of S here. Okay, so we want you to plot a graph of V against H. You can take one graph paper and try to draw. Okay, and then you can check the answer. Okay, let's say you have a graph paper. Okay, so what should you do in order to draw a graph of V against H? If you look at the title V against H, meaning the y-axis must be V, the x-axis must be H, because for graph we always read as y against H. So what you do, you need to label and write the correct unit. V, the unit is centimeter second to the power -1. H, the unit is centimeter. Based on the value of data or the range of data that you have, you need to set a scale for the graph. Okay, you must choose the graph which is not odd scale. What is odd scale? Odd scale means 2 cm equals to okay, maybe 3, 6, 8. Okay, odd scale does not mean odd number. It means the scale very hard to read. We call it odd scale. Okay, now you transfer all the points correctly. We have 5 points just now. Use cross. This one I just want to show you. I put like a circle here. So you use cross X. Okay, you have 5 points here. Next, draw best fitted line. The best line that you can draw, meaning if can pass through all the points, that one is the best line. If cannot pass through all the points must be balanced above and below the line. Okay, so what we can get from the graph? Before that, let's look at okay, how we mark this graph. The best graph should have a label and unit, both exist. Best fitted line. You must transfer all the points correctly. The scale must be uniform and not odd scale. And then the size of the graph must be large. How to know whether it's large or small? Okay, you must draw a graph until it intercepts at v-axis. Don't draw hanging graph. Okay, a large size of graph meaning we measure from here until the last point here. It must cover more than 5 larger square. Here we can count 1, 2, 3, 4, 5. So more than larger square. The horizontal part also more than 4 larger square. So here is 1, 2, 3, 4, 5. Okay, so this one is large graph. Okay, so this is how you plot a graph. Okay, what we can get from the graph for the part of analysis of graph. So the interpretation of the graph means based on the graph that you draw, you need to state relationship between V and H. So from this graph, we can write as V is increases linearly with H. Now we want to determine the gradient of the graph. How to determine the gradient? The first step, draw triangle below the line. The size of the triangle must be large, more than 4 times 4 larger square. The larger the triangle, okay, the more accurate the value of gradient. Okay, now write down, you calculate the gradient. This one we call it substitution part. You must show the step of calculation. So m equals to 70 minus 20, that one is the height, divide by 50 minus 0, that one is the width. Okay, so we get 50 what? 50 V, centimeter second to the power -1. And then here is 50 centimeter. So the centimeter can be cancelled. So we get 1 second to the power -1. Okay, so you can see we write the answer with unit. for gradient. And then the third one, precautions. When we carried out discussion to discuss about why the result is not accurate, for example, so we can state some of the precaution taken. For example, eye level perpendicular to the scale of meter rule to prevent parallax error. So for this experiment, we use meter rule. Then we can write meter rule. So you can use this one, this precaution for all type of experiment. But the instrument here, you must change according to what used in the experiment. If in experiment using ammeter, then you put ammeter here. Okay, you must write the precaution completely. Okay, this activity 1.3, you can see this activity in the textbook. Okay, so you can try to answer this activity 1.3. Okay, from here, the table of data, you can plot a graph of f against x. And then you can analyze of data based on the following aspect here. This one can be one of the PBD. Okay, you can present your graph and the analysis with your teacher. So I think I will stop now for this topic. So I hope you can do more exercise on this so that you will understand better. I will continue. My next video is about scientific investigation part 2, where I will carry out experiment 1.1. That's all for today. Bye.